welcome to the second part of our crash course on electric circuits. So remember in the first part, we talked about the different components of an electrical circuit, the different types of electrical circuits, and the properties that we can find in those electric circuits. So in part 2, we're going to put all of those things together and tackle some of the formulas that we use to calculate certain things. We're going to look at Ohm's law, electrical power, and electrical energy. So let's get started. So the first formula we're going to look at is Ohm's law, and Ohm's law is a mathematical relationship between the potential difference, resistance, and current intensity in a circuit. So before we jump into the formula, the first thing I want to stress is that when we are dealing with formulas in science, it is so important that you make sure that you understand the units of measurement associated with each variable. So in potential difference, we're talking V for volts. Resistance, we have that Greek shape, which is ohm, and we have current intensity, and the unit of measurement is A for amps. So let's talk about the formula. So the formula that we use for Ohm's law is the following. So we're going to do V is equal to resistance times intensity. So that is the formula that we are going to be using and we are going to be manipulating in the next couple of examples. Let's have a look. So let's do our first example. A 12-volt battery is used in an electrical circuit. An ammeter is used to measure the current intensity, and the result is 9.6 amps. What is the value of the resistance? So first thing we need to do in any situation in science is write down what we know. So we're going to write down what's given in our question, and we look at the units of measurement to help us. So we know that a 12-volt battery, that's our voltage. So we're going to write 12 volts. Really important to write that unit of measurement next to it. Then we also know that we have the intensity in this question. So we have 9.6 amps. So we're looking for resistance. So we don't know what that is. So I put our formula over here. So the key is whenever you have three variables, like in this situation where we have our formula has three different things that we can solve for, voltage, resistance, intensity, we're going to cover what we want to find. So we want to find the resistance. So what does that mean? Well, it's going to be voltage divided by intensity. So that's going to be the formula that we're going to use. We're going to manipulate our formula and we're going to say, okay, I want to find resistance. It's voltage divided by intensity. So if we look at our solution, we're going to take our formula, our original formula, voltage is equal to resistance times, and we're going to move it around. We're going to manipulate it, like I just said. So we're going to do resistance is equal to voltage divided by intensity. We're going to plug in our values. But first, a question break. What units are used to measure resistance? Is it A, amperes, B, volts, C, ohms, or D, ohms? But take a look at the symbols. Take a look at the units of measurement. The answer is D, ohms, with that Greek symbol there. So if we substitute our values into our equation, so we get 12 volts divided by 9.6 amperes, we get an answer of 1.25 ohms. So the resistance in this electrical circuit is 1.25 ohms. So let's look at a second example. A TV remote control uses two 1.5-volt batteries to generate an electric current. There is a 20 ohm resistor in its electrical circuit. Determine the current intensity. So again, we're going to write down what we know from the question. So here we have our voltage, and our voltage in this case is 1.5, but I have two of them. So I have 3 volts of power here. Then resistor, we know that the resistance is measured in ohms. I have 20 ohms in this question. And I'm looking for intensity. So I'm going to go over to my formula, right? We remember our formula is V equals R times I, but this time I'm looking for intensity. So I'm going to cover up intensity, and I see that it is voltage divided by, remember this is divide by, resistance. So intensity equals voltage divided by resistance. I'm going to take my values, substitute them in. So 3 volts divided by 20 ohms. And I get an answer, if I put those in my calculator, of 0.15 amps. So the current intensity in this electrical circuit is 0.15 amps. Our next formula that we're going to tackle is one that is used to calculate electrical power. So electrical power is the amount of work that an electrical appliance or device can perform per second. And so we have a formula for you that it's another one. So you're going to have another one to look at. And it is, P is equal to V times I. And remember, our units of measurement are also, again, very important. So electrical power, which is our variable here, is measured in watts, so a capital W, or kilowatts, which you have probably seen before. And then we also have potential difference. That doesn't change. It's measured in volts, and current intensity is measured in amperes. So let's do our first example. A typical hairdryer plugged into a 120 volt outlet uses 1750 watts of electrical power. What is the value of current intensity flowing through it? So again, we're going to write down what we know. So we know that we have power. We have 1750 watts given to us in this question. We also know that we have 120 volts of power going through it, and we're looking for our intensity. So again, we're going to go over to our pyramid for our formula to help us manipulate it. So in this case, remember that power is equal to voltage times intensity. So we're going to look at that relationship. Let's look at how we manipulate it. How is current intensity calculated based on the electrical power formula P is equal to V times I? Is it A, I is equal to P times V, B, I is equal to P divided by V, C, I is equal to V divided by P, or D, I is equal to V times P? The answer is B. So we're going to take our manipulated formula. So intensity is equal to P divided by V. We're going to plug in our values. So we know that P is 1750 watts, and we divide that by 120 volts. We put that in our calculator. We remember that intensity is measured in amperes. So we get 14.6 amps. So the current intensity in this electrical circuit is approximately 14.6 amps. So now we've come to our final formula, which is a formula to calculate electrical energy. It is probably the most practical one as well. So it's the amount of energy transferred to the appliance or device from the electrons during the time of operation. And so our final formula that we're going to teach you about is energy is equal to power times the change in time. And so there are a lot of different units that you have to remember in this because they can be kind of tricky, but I'm going to try and help you through this. So first thing you need to remember, anytime we're dealing with joules, we're dealing with seconds and watts. So those guys are a combo deal. And then if we're dealing with kilowatts or watts, then we're dealing with hours. So we're dealing with two different separate kind of units of measurement, but they both mean the same thing. So let's do an example and kind of sort through it all. So let's do our first example. A 1200 watt air fryer is used for 12 minutes. How much electrical energy does it consume? So the first thing that we always need to think about when we deal with electrical energy problems is the time. Is the time in seconds or in hours? And if it's not, then we need to convert either to seconds or to hours. So the first one we're going to do, we'll convert to seconds. So we want to know how much energy, so we don't know that. But we do know the power. We do know that it's a 1200 watt air fryer. And we do know the time. It's 12 minutes, but I don't want minutes. So I want to turn this into seconds, so I'm going to times it by 60. So I get an answer of 720 seconds. So I've done my transfer, so I've made sure that my units all line up. So my time is in seconds, so that's good. I have my watts, and I'm looking for my energy, electrical energy calculation. So I'm going to put it into that formula that we had before, which is energy is equal to P times time. So I'm going to take my 1200 watts and I'm going to multiply it by 720 seconds. Now you remember in that table in the last slide, I said watts and seconds go together and they turn into energy, which is measured in joules. So if you put 1200 watts times 720 seconds in your calculator, you're going to get 864,000 joules. We can also look at it from the perspective of those different units of measurement. So we said that we have seconds here. We'll do this the next one in hours. So if we look at energy, we're looking for we're always looking for energy again, but instead of using 1200 watts, we're going to convert that 1200 watts into kilowatts. So we're going to divide 1200 watts by 1000, and that gives us 1.2 kilowatts, because remember, kilo means 1,000. And then we have our change in time. So instead of turning it 12 minutes into seconds, we're going to turn it into hours. And 12 minutes is equal to 0.2 hours. So again, same thing. We're going to put it in the exact same formula. E is equal to P times T. We're going to take 1.2 kilowatts times 0.2 hours, and that is going to give us 0.24 kilowatt hours that the air fryer uses in electrical energy. Now, Hydro-Quebec likes to use this. So if you wanted to find out how much energy your house is using, Hydro-Quebec sometimes charges 8 cents or 9 cents per kilowatt hour. You can find out how much your energy bill is going to be. So you would take your 1.24 kilowatt hours and times it by 8 cents, and you would find out how much that air fryer cost you to run. So let's look at a final example that comprises all three formulas that we've looked at today. A washing machine plugged into a standard Canadian outlet takes 45 minutes to complete a full cycle. The intensity of the electric circuit is 5.5 amps, and the resistance is 20 ohms. Determine the amount of electrical energy consumed by the washing machine over the course of a year. Now remember, a year has 52 weeks, if it is used twice a week. So I've already written down what's given to us. We know that we have 5.5 amps. We know that there's 20 ohms. We're looking for energy, okay? But we have that 45 minutes of time. So we need to remember that we need to either go seconds or seconds or hours. We're going to go hours. It's more practical. So we're going to take that 45 minutes and we're going to use all these three formulas as well, but we're going to go and do the time first before we get into those formulas. So we're going to tackle the time. So 45 minutes is, we're going to put it into one cycle. Okay, so we're finding out how much that is per cycle, and it's 0.75 hours per cycle. So we did the conversion here. Now we have 2 times a week over 52 weeks. So we need to take that into consideration as well. So 0.75 hours per cycle times 2 cycles times 52 weeks, we get 78 hours a year that this washing machine is running. So I can put 78 hours in my time that I know. We're always adding to our givens. So what else can I use? What else can I find? Well, I have enough information in this question to find my voltage because I have my intensity and I have my resistance. So if I look at my formulas, I have enough information to find voltage. So let's tackle that one first. So let's use that information, so the intensity and resistance, to find our voltage. So we're going to use the voltage, or we're going to use that formula, so Ohm's formula. Voltage is equal to resistance times intensity. So we're going to take the 20 ohms and we're going to multiply that by 5.5 amperes, and we get 110 volts. So now I have enough information. If I go back into my formula bank, I have intensity and voltage. I can now find the watts. I can find power. So I can take my power formula, P is equal to V times I. I can take that 110 volts times 5.5 amps, and I get 605 watts. So again, I can come back to my formula bank and notice that I have power and I have time. So I have enough information to find energy. So I'm going to take that information, I'm going to plug it into my formula of energy is equal to power times change in time. So I get 605 watts, but I'm going to turn those watts into kilowatts. So I'm going to divide 605 watts by 1,000, and I'm going to get 0.605 kilowatts times 78 hours. And I'm going to get an answer of 47.19 kilowatt hours. So you remember that this is the most practical. In real life, we use kilowatt hours the most. That's what Hydro-Quebec uses. That's what you see on energy efficiency labels. So we want to make sure that we stay consistent. Kilowatt hours. We want to make sure that those units of measurement always stay seen so that we know what we're calculating. So at the end of the day, this washing machine uses 47.19 kilowatt hours of electricity. And there you have it. You have successfully completed both parts of the electrical circuit crash course. So just keep in mind that when you're studying for your ministry exam, that those three formulas that we just did will be given to you so that you can use them. You just have to know how to manipulate them properly. So that you need to practice. So just to resume, we talked about Ohm's law, we talked about electrical power, we talked about electrical energy, and we also talked about the units of measurement and how important those are when we use our calculations. So happy studying. Make sure to check back and practice if you need to.